have two recordings here, one by Anderson and one by me. So we should be covered. All right. So welcome. First of all, welcome to UCLA. Most of you did not go to UCLA, so welcome. UCLA is a very, very special place. So enjoy your short time here, at least in this program, because it goes by really, really quickly. And it's just a really nice environment, both on campus up here especially. The whole campus is nice, but this is the really nice part of the campus, and North Campus in general. Welcome to MSBA, Anderson and MSBA. I know that a lot of you are excited to get started, and so am I. Some of you are also new to California, or maybe even the U.S., so welcome. I love California. I've lived here my whole life. And before we get started, and welcome to 402, obviously. Before we get started, I went through the slide deck containing all of the new student introductions, and I don't remember any names yet. By the end of the quarter, I will, because you all are going to be with me next quarter as well. So I'll probably know all of your names by the end of next quarter. All right. So a couple of interesting things that I found while going through these slides, things that are similar to me. There's a couple of you that are interested in planes or aviation, 2 of you. So that's cool. I think a couple of you are CS majors. I wrote down 2, but I think there were a lot more than that. 11 of you also went to UCLA for undergrad, so you're like the tour guides that can fill everybody in on what's cool to do in LA or on the UCLA campus. Let's see. 2 of you are from Chile. I'm not, but I thought that was interesting. 2 of you have some connection to Mexico. I'm half Mexican, and that's the only side I know. So I thought that was interesting. 1 of you is actually from a city very close to me, Simi Valley. I'm originally from Thousand Oaks, so it's really close. 3 of you have worked at Amazon, either as internships or full-time. That's pretty cool. I'll talk about that in a moment. 3 of you went to USC for undergrad. Not necessarily this group plus the other group. So 3 of you, 1.5 of you in this group, went to USC. 1 student even referred to themselves as a brogen, which I just absolutely love. I absolutely love that term. 2 of you listed that you like cycling. Now, I'm upset that nobody said their hobby was mountain biking, because that's my hobby. Let's see, 2 of you went to Berkeley. I think maybe there might be a couple more that I missed. 1 went to UC Santa Barbara, and I have a little bit of a story about that. That was actually my dream school coming out of high school. And I did go there for a year, and I left after a year and transferred to UCLA. But I do miss it. It's a very nice environment. A lot of you like skiing and snowboarding. Now, I am not a winter guy. I don't ski and snowboard, but you would like where I live, up in the mountains, because that's where people go skiing and snowboarding all the time. So that was interesting. A lot of you play the guitar. I have 3 guitars and don't know how to play any of them. I have an acoustic, a bass, and an electric that I need to learn how to play. 1 of you says you cannot function without coffee, and yeah, that's me as well. And then 4 others also like coffee. So, I'm not a coffee snob, but I need coffee. What is this? I'm Ince. 1 of you said your favorite cocktail is an old-fashioned, and that you like bartending and whiskey. Okay, I like those things too, but I have to say, this person they're a little young. I mean, they're over 21, but whiskey, I don't know, at least in the US, it has this reputation of being kind of an, 35 and up or 40 and up type of drink. So I thought that was hilarious, but you have good taste. A few of you are from the Bay Area, Santa Clara University, from San Jose or Mountain View. I lived in the Bay Area for a couple years. I'm glad I'm back down here because it's much cheaper, though I do love it up there. Mountain View in particular I lived in, which was beautiful. 1 of you is a diehard Rams fan, and I hope if you're from LA, you are. I really like the coach. What's his name? Sean McVay. He has this blonde, spiky hair that I used to have when I was younger, and he talks a mile a minute like I do. So, we're kindred spirits. Somebody fell in love with Edinburgh when they were traveling, and Scotland is my favorite country in the world to visit. I've been there 6 times, and yes, Edinburgh is an amazing place. So we can talk about that if you ever want to. What is psychedelic rock? What is a psychedelic rock band? I've never heard of this genre. Oh, okay. I thought it was something brand new. Yeah, that would make sense. Okay, cool. All right, so let's go ahead and get started. So I thought that was, interesting to share. I don't have much interesting. Well, we'll talk about me a little bit, but I don't have much hobbies that are interesting to share except for mountain biking and gardening, I guess, and traveling all over the place and staying up late at night, teaching various classes. All right, so let's go ahead and get started with the slides. This is actually we're starting off here very chill. We'll pick up the speed as we go. But it's a very chill lecture today. It's the first lecture, and I always keep it kind of light on the first lecture. So we'll talk about the syllabus and logistics. Because it's an 8 a.m. class, I'll say I'm trying to protect the environment. I didn't make 65 copies of the syllabus. Really, there's a couple things we're still not sure about, so I can't put it in the printed syllabus yet. The syllabus is available on Brew and Learn, so I'm glad everybody brought their laptops. You should be able to see the syllabus on there, and we'll go through it as well. So it's posted on Brew and Learn. Please read and review it. It's very uncommon that people read syllabi anymore, so I have a way of controlling for that that I'll talk about in a moment. You're responsible for the policies in it. There's also a student survey. Now, some of this is redundant because they passed around that slide deck that basically says what degree you have and where you came from and where you originally came from, like the country or the city or whatever. But we'll do it again just to be complete. It asks you a variety of other questions about your technical background. A lot of you have a lot of experience. It's not clear to me if it's internship experience or full-time experience. So that was interesting. So tell me about that, a little bit in this survey. And some of you don't, and that's totally, we don't expect anything coming in except whatever it was they used to admit you. We expect you to have that. Let's see what else. Some of you have SQL experience already. Some of you quite a lot of SQL experience, and some of you have none, and that's okay too. I'll talk a little bit about that in a moment. So anyway, you'll get 10 points towards participation. So you can start the quarter off with 100% in this class by filling out this survey as completely as you can. So maybe you don't want to answer an optional question or two, that's fine. But if you answer most of it, you'll get the 10 points. So just to fill us in. All right. So if it says click here, I don't know what happened to the links here. There is a link here. Oh no. What happened to my... there it is. All right. Also, I apologize that we're offering an 8 a.m. section of this class. It's what the system chose. There's an optimization system that chooses these classes, and so I have one. So on Wednesdays, I teach 3 classes, which isn't unusual if you're full-time, but I actually work a full-time job outside of this, and I'm teaching 3 classes, so it's a little it's a little frazzled. I teach until 9:30 here, 4 to 6 computer science, and I'm not done yet. Then I teach from about 7 to 8:30 or something back here again. So it's it's going to be interesting. A lot of coffee and not a lot of sleep, basically, is what's going to happen here. Hopefully next quarter, we have better times. So, I got back my computer science students. Some kind of there was some. I don't know what you would call it, not revenge, that's too mean of a word. The system got revenge on the computer science students because they have an 8 a.m. section. There's only 2 of them. So at least I don't have to teach that one too. Anyway, SQL is extremely important for data analytics. So you're going to use it throughout your career. It's very unlikely that you're going to be able to avoid SQL. Now, some of you maybe more on the machine learning or generative AI side, or maybe more the software engineering side of analytics, and it is possible that you could find a role that doesn't use much SQL, but it's very rare. You'll at least have to write a select statement to get data out of a database in order to train classifiers. So my job currently requires a lot of SQL. Previous jobs as a software engineer did not. I had to pull a lot of data using MapReduce jobs, using a SQL layer, and that's where I ended up getting really good at it. But it's very difficult to avoid it. So you need to get good at it, not necessarily this class used to be 5 weeks. So what I would say is you don't need to get good at it in the 5 weeks of the class, but throughout the program you need to get good at it. Now it's 10 weeks, so hopefully you absorb more. All right, so it's usually tested in interviews, especially in data analytics. I mean, I'd be very leery of any company that doesn't test SQL for a data analytics job. And I've seen a lot of great candidates that just do not do well on the SQL part of the interview, and they end up not getting an offer. This is why we teach SQL in the CS department as well, is because a lot of companies test SQL, and a lot of these students do not have SQL. They never learned it in their undergrad, and they end up not passing the interview. It's very easy to make errors in SQL, very easy. And I'm not talking about the type of error where you type in the query and you get an error from the database system. I mean a runtime or logical error where the SQL query doesn't do what you want it to do or is very inefficient. So it's very easy to write a query that just will never end, that either crashes the system or just is gonna take 6 hours to run when it should have taken 10 seconds. It's very easy to do that. And in my very first internship, this is before I got good at SQL, I did crash the database server at my company. This was a startup that did not separate production and development databases, which means that when I crashed the server, I crashed the entire company's infrastructure. Now, I didn't get fired for that because it was their own fault for not having redundancy, but it wasn't a good situation. But pretty much everybody that works in analytics at a startup or a software engineer at a startup has crashed the database system. So, if you go to Google or a big company, you shouldn't have to worry about that. But it happens at smaller companies. So my goal here isn't just to teach you SQL. It's also to give you a thorough coverage of it, but also emphasize some areas that can get you into trouble, and also emphasize areas that are typically covered in interviews. So there's a couple of things that I've been tricked by in interviews that I'm going to cover in this class, or that I've seen candidates not do well on. So if you're more on the computer science side, there's a lot more computer science people this year than usual. If you're more interested in the real technical aspects of how a database works under the hood, you can click on this link. So this should be a link, and watch the videos from CS 143, which is a databases infrastructure class. So you have to log in with your Google account, and I'll get to that in a moment. But I don't have to cover everything under the sun in this class because I'm teaching 405 as well. So if I end up missing a couple things or we don't get to a couple things, we'll just end up covering it next quarter because we need it anyway for next quarter. So that's 405. So going back a minute, this is mostly a SQL class, but there's also a couple of other theoretical things that we're going to talk about. Something called functional dependencies, which are rules for how two columns are related essentially, or multiple columns are related in a database, and the normal form. So this is what's called schema design. How do you create a good schema that's efficient and minimizes redundancy in a database? We're also going to talk about a concept called relational algebra, which is kind of like math and logic. We'll probably talk about that next time. This topic's a bit controversial with students, but it's interesting what we learn after we go through interviews and whatnot. The first time I taught this class, I went very thoroughly into relational algebra. The students hated it. And I got probably 5 or 6 times, when are we going to use this? Why do we need to know this? So I decided, maybe they're right. I won't cover it as heavily the second time I teach it. Well, that didn't make them happy either. They said, no. We heard that the relational algebra part was extremely important. Please don't, lower the standards there. Okay, so now this year we're going to go back to a more thorough coverage of relational algebra. And trust that you will use it. Talk to the alumni, who I don't think are here anymore. So, it's a lot of this. It's a lot of symbols. What else do we have? We have pi. We have rho. We have this x. We have this and this. Anyway, it's pretty cool. So if you were a math major, or really like theoretical math, you'll like that, but we're not going to do proofs or anything like that. So this course requires no previous experience with any kind of database system whatsoever. A lot of you already have some of you have a lot, so there's a wide variety, it's like a bell curve of technical ability in this class. But, we're going to start at basics here so that everybody is on the same page. Sometimes people misjudge their own experience. I see that a lot. And they find out, well, I did play around with SQL, but, really, I really need to do better at it. So that's what this class is for. I do try to address everybody's needs, though. So if you're super, super advanced, there's like bonus problems and stuff. And you can always talk to me in office hours, and I might send around articles about more advanced SQL or databases stuff. For those of you that are interested, and I will always preface it with, this is for the more advanced students, you're not going to be tested on it. type of thing. But I want this class to be interesting and enjoyable. One idea originally that we had was, should we let people test out? We decided against that. Even some of the students didn't like that idea, presumably because, we want everybody to be on the same page and be one community or one cohort. And there's two cohorts based on your schedule, but you're all kind of one community. So the goal here is to do well, to learn enough SQL so that you can do well in future classes and be able to pass interviews with internships and job interviews. I've had several students, there's only one projector, okay, cool. I've had several students approach me saying, yeah, I had a SQL interview and I was able to pass it because of your class. I even had somebody who said, I think she interviewed for TikTok, which is difficult to get into. And she said that they gave her like an hour to do this SQL test. And she was able to complete it in, I think, 30 minutes or so. And that they were really impressed because most people can't complete that interview in an hour. So that's what I'm going for here. Hopefully you find the same success that they did. All right. All right, so getting into the meat of things here. This is my email. It's in the CS department. You can email me. I don't say don't email me, but please keep it minimal. I get a lot of email. And there's a couple reasons why I'm asking you not to use email that I'll get to in a moment. You should only use email for stuff that's private, so stuff that you need to discuss with me. So setting up appointments, I'm having a hard time with this, meaning I can't make it to class or whatever. Stuff that's very personal that other students don't need to know and shouldn't want to know. So use that email for that. I do have an Anderson email if it's easier to remember that gets forwarded to my CS email. So my office hours this quarter, and I've checked your schedule, so this shouldn't conflict, is Wednesday 2 to 3 p.m. in person in Belter Hall. I'll tell you where that is in a moment because it's nowhere close to here. And then also Thursday 5:30 to 6:30 on Zoom. So Wednesday's in person, Thursday is on Zoom. You can also make an appointment with me, or if you want to attend Wednesdays but you can't come in person, just let me know and we can set up a Zoom session as well. If I end up changing these office hours, I'll let you know in writing, but I don't think we need to do that. Hopefully. You'll let me know. So where on earth is Belter Hall? It has a reputation of being the place where dreams go to die. Or it's scary, and it actually, it kind of is scary late at night. And sometimes, basically the computer science department 8 years ago moved out of Belter Hall into a new building. Some of us the database people were all left behind in this building. And the third floor where my office is almost entirely vacated. So there's a lot of empty office space. There's a little museum around the corner about the UCLA being the birthplace of the internet. So you can go take a look at that at your leisure if you come visit me. It's kind of cool. There's a lecture hall down there, a research lab, and that's really it. The entire rest of the floor is vacant. So I'm still there. We are up here in Anderson, and it's too complicated to give you directions of how to get to Belter Hall. Try to find an alum or take a walk down there and experience it. If you go in between Kaufman, which is one of these, you go out the main Marian Anderson Hall, make a left, across the little bridge. You go in between these two. Is it Royce and Fowler? Royce and Fowler. Is that? Yeah, I think that's right. So you'll see Jan's steps if you do that. And basically you just keep walking south forever. It is if you've been to the UCLA store, which is in Ackerman Union, or know where the bear statue is, it's kind of close to there. Anything else that you might know? The Luskin Center, so that hotel that has the bar, that's also right across from Belter Hall. So Math Sciences, it's down there. It's on the third floor. It's going to take you a little while to find it. It's a very complicated building, but just find an elevator and go down to the third floor, and eventually you'll run into my office because it forms a circle. It's 3531A. All right. It has a suite, so there's a door on the outside and a little waiting room, and then there's my office. But it'll be open for you. So if you see that, don't be alarmed. So anyway, enjoy your time here. Especially be thankful for being in this nice part of campus, because the lecture halls and other facilities are not as nice elsewhere on campus, especially down in that section. There is a piazza for this class. Last year I used Campus Wire. I didn't particularly care for it, so I've switched back to Piazza. You've all been added to it already. There's a link on Brew and Learn to it. This is where you should ask all of your questions regarding course logistics and course materials, and the homeworks, and you're confused and whatnot. Ask there. The reason why we use Piazza and the reason why I discourage using email is we want every student to be able to see what other students ask, because you probably have the same questions. So this allows us to answer each question once rather than 5 million times, 130 times. Both lectures are in the same Piazza instance, so you're all together. If you have trouble using Piazza, let us know. Or if you have trouble getting in, let us know. So for course questions, clarifications, confusions, please use Piazza. If there's a grading issue or you have questions about grading, there is an option to use a private post to instructors. Please use that. Please don't post it publicly or send us email. The TA and I need to both see it. I also might use Gradescope for that as well. How many of you have used Piazza before? Oh, wow. I thought it would be a lot more. Okay. What about CampusWire? Even that's really low. Wow. Okay. So there might be a learning curve here. That's okay. We will help you use Piazza. It's pretty easy to use. And if there was any questions, please feel free to jump in and let me know. One warning here, and we'll get to this in a moment. Please don't post code or your answers to HW on Piazza. This was a problem last year because then other people can copy it. Yeah.
Is there a way I can change my email associated?
Yes. I don't know how to. You can add an email. I don't know how to do it. Send me an email or send Tommy an email. It's better to probably send Tommy an email because he's our TA. You'll see his email in a bit. Yeah, so if you don't want to use the email address that's on the Canvas official record for my UCLA, you can add another email address, and then you can get all the notifications there. You can customize the notifications so every time somebody posts something, you may get an email about it, and every time somebody responds, you may get an email about it. You can change all that so that you're not bombarded with email. I've actually had to do this for my mental health. I get way too many emails from Piazza. It's too much. So I had to turn off the notifications. And Tommy, I'll ask Tommy to go over that in the your discussion sections next week. But we'll let you know basically how to do that. We'll send an email and how to add a different email address if you don't want to use the UCLA one. I should point out, for those of you that are new to UCLA, you have an Anderson email, which you already know. You should also have what's called a BOL email, which is a g.ucla.edu email address. If you don't have one, you have to sign up to get one. This is going to give you access to the Google instance, so the Google Drive instance. Your Anderson email won't give you access to that. Again, you can link the two accounts, but you'll have to ask somebody else how to do that. So, speaking of the devil, you all have free access to Google Drive. I post everything on Google Drive. So the slides are posted on Google Drive. The homework is posted on Google Drive. Everything's posted on Google Drive. So it's always accessible to you via links. If I make changes to the materials, it's very easy for you to have an up-to-date copy because it just syncs to Google Drive directly from my laptop. Okay. So you need to routinely log into your UCLA Google account. A lot of times what happens is people try to view things and you get that error message, access denied. That's because you're not logged into the right account. You can't access it from your personal account. All right, this is your TA. His name is Tommy Vautran. He's a computer science master's student. This is his third time TAing with me. He TA'd 143, which is basically databases with me, so he knows SQL really well. And he was my student at one time in that class. And he's TA'd for an online master's program for that class. So it's a professional program kind of like this. But basically it's the same class I teach in person, just online. They don't come in person. So he's TA'd for that program as well. So he has some experience TAing for professional students or graduate students. He also TA'd a web apps class for me as well. So we have a history. His email is here on the screen. So if you're already having issues with Piazza or you want to add an email address or any of that kind of stuff, feel free to email him and he will get back to you. His office hours, these are tentative. This university has no space. So we're trying to find a room for his office hours. He doesn't have an office in CS right now because he's not TAing there, and the discussion section. So his office hours are 11:30 to 12:30 on Tuesdays, and the discussion section is going to be Thursday, so like tomorrow, but next week, starting in week 2, on Thursday from 11:30 to 12:30. But discussion section is not mandatory. It's just like with undergrad, and it's not scheduled. It's not scheduled on the mainframe, unfortunately. But what you're going to talk about in there, do I have a slide for that? I don't have a slide for that. What you're going to talk about in there is he's going to go through exercises pertaining to what I covered, either the previous week or the previous day. We haven't decided. You're going to help him figure that out, what the format should be. And he'll go through exercises. He'll summarize what I talked about. So it's really good to have a second opinion about the material, especially coming from somebody perhaps closer to your age. It just makes it's more engaging to have 2 points of view on this material. And he's really good. What else will he cover? Oh, if there's technical issues, there's usually a lot of technical issues. Not everybody, knows Unix or Linux and stuff like that. He'll help you with those as well by doing demos or just essentially turning the discussion into an office hour session, a tutorial session. Yeah.
Does the discussion start this week or next?
Next week. So it starts week 2. We probably could have started it tomorrow, but I don't think there's going to be a whole lot to talk about yet. So next week. Okay. Right, so student and instructor feedback has actually led to a lot of changes in this class. A lot of changes to this class. Last year was very frantic. The students were very, very frantic, pretty stressed out in my opinion. My TA and I were also pretty frantic and pretty stressed out because of how condensed the schedule was. And it just was not enough time for anybody to do their jobs right, us and the students. So every lecture was 3 hours long. We had a 10 to 15 minute break in the middle. Nobody could get through the lecture. By the end of the first hour and a half, everybody was dozing off or kind of like giggling because they're like so tired. I get it, because I'll get to that in a moment. And just couldn't absorb the material, especially the people that were newer to SQL. So that's just not fair. It's not right. And then their grade depended on that. Right, so, and then on my end, the 3 hour classes were back to back. So I was on my feet for 6 hours straight. And in the second session, which usually actually went a little smoother because I had practice from the first section, I was so tired that I was practically giddy. I was just like, kind of just falling all over the place because I could not stay awake. I was trying to keep myself awake and making really dumb jokes, but we had fun. So a little more sane, and it was over 5 weeks. So now we have an hour and a half each week together for over 10 weeks. So you have 10 weeks to learn this material. So this means you have more time to work on homework. That was a really big problem. The homeworks weren't easy. So now you have more time to work on the homework, maybe a week and a half to 2 weeks. Or I'll split up the homeworks and make them due weekly. I haven't decided yet. And it gives you more time to absorb the material. So only an hour and a half that you have to deal with me. You can read on your own, and then the next week we pick up again with the new material. It's a lower cognitive load. You're not always on for this class. It's a 2-unit class. It shouldn't be that stressful. There was a final exam, and there will be a final exam, but now we're also gonna have a midterm, which I know is a pain because there's 2 exams, but it's gonna give you a diagnostic of where you stand. So if you don't do well on the midterm, you can improve on the final. That's really good. Students usually improve on the final, even though the final is usually a little harder. Whereas last year it was perform or die. Here's the exam. And if you didn't absorb the material, it was kind of oh well. It wasn't a great situation. Right. So we're receptive to feedback, both me and the leadership, about how this format goes. So if we can maybe keep it for next year. And if there's a way to provide a better experience if need be. And if you think there's topics that are missing, let me know. What's a little bit different is we can't just split the material in half each week. What may actually end up happening is you all absorb the material so well that we don't have to cover it as well in lecture. So we may actually be able to cover additional stuff. It's a little bit of a weird mind trick or mind experiment. Anyway, this slide unfortunately is never going to go away at this point. If you're sick, please don't come to class or office hours. There's other ways to catch up. We have recordings, we have slides online, and we have office hours. So I don't care if it's if you're dying, obviously don't come to class. But even if you have just the sniffles, please don't come to class. Unless you absolutely know it's allergies, which is a really big pain here on campus. So we'll add discussion section on this slide. All right. So how is your grade computed? First of all, you're graded somewhere between an undergrad and a grad student. What I mean by that is undergrad students are graded A, B, C, D, F. There's usually some kind of, I don't want to say a curve, but there's some kind of stack ranking involved there. I'm not saying there's not here, but it's a lot more strict there. It's much easier to get a C or a D or an F in an undergraduate class. In a pure academic program graduate class, so we're talking computer science, not these more professional programs, graduate students usually get a minimum of a B minus. It's actually usually more like a B plus or a B, but a B minus is usually the minimal acceptable grade. Below that, the department's going to start asking questions. So we're not as lenient here, unfortunately. There actually is a suggested grade distribution for this program. I typically don't stick to it. I go a little higher, but it's something like 5% is a C. C is considered unsatisfactory for a grad student. I believe you get units, but you don't get degree credit if you're in the C range. I think maybe it's C minus. I don't remember, but you want to stay out of the C range. That's 5% basically. 5%, I think. I don't remember. But it's mostly A's and B's in graduate level classes. This program is a little bit more competitive, so we can dip a little lower with the grades if we need to. And I have had to do it compared to other graduate classes. So just really try to keep up and put in the work, and you won't have to worry about that. 10% is on attendance and participation. So what do I mean by this? I don't track attendance in every lecture. I sometimes do as a freebie. So it's free points, basically, if you're here. But there's other ways to get credit in the participation grade as well. So things like filling out the student survey. We may ask you to fill out surveys throughout the quarter about various things. We're going to ask you to set up a dev environment for MySQL. Showing that you did that on a timely manner will get you credit as well. So it's an easy 10% if you're doing what you're supposed to be doing. And this also allows me to break ties if you're between two grades. 35% is homework and programming assignments. This is lower than I usually have it, and there's various reasons for this. Because we have a midterm mainly. 25% midterm, this is going to be on Monday, October 28th. It is not held during lecture. 6 to 7:30 p.m. in Crown Auditorium. I don't know where that is, but I'll figure it out. You'll all be in the same room. And then 30% final exam. This is tentatively December 11th. There was a bit of a misentry in the mainframe. I was not assigned a final exam through the registrar's office. Anderson has one scheduled for me, but it conflicts with my other class in CS. So we can't have that. So we're figuring out when the final exam will be. It's probably going to be December 11th, probably in the evening. I'll send out an email as an official course record as to when that is. So grade cutoffs are based on my expectations. It's not based on even though we have a recommended distribution, it's not based on top 20% is A, next 40% is B, and the rest is a C. So that would be 40, that's too much. It's not based on that. It's also not based on if the lowest student in the class gets a 90%, they get an F. That's not how this works. Everybody would just get an A in that situation. So it's based on my expectations, and I look over all your work, and I set the grade cutoffs for each exam in the homework grade. Okay, was there anything else I wanted to say there? Okay, I already covered it. For this class, we're going to use MySQL. I actually prefer Postgres, and that's what I usually teach in CS, because it's very standards compliant. Any textbook that you pick up teaches the SQL standard, which every relational database implements. They don't implement it perfectly. Sometimes they don't implement the entire standard, and they make up their own stuff. But if you know of a SQL standard, you can use MySQL, you can use Postgres, you can use DB2, you can use Oracle and Microsoft SQL Server. It's translatable. So even though we're going to use MySQL as the backend, as the database itself, I'm going to teach you and you're going to use SQL standard syntax, not MySQL specific syntax. And I do take off a little penalty if you do something MySQL specific. I really want this to be translatable to other database systems. I would hope that if you go into a SQL interview and you use MySQL, that they won't, if something MySQL specific, that they won't complain too much. But let's just try to avoid that. Let's write SQL standard compliant code. If I do teach anything that is MySQL specific, I will tell you. And then I'll let you use it if I teach it. So there's homework. It's a mix of conceptual questions. So when we talk about relational algebra and the relational model, we're going to do that. It should be treated as exam prep, and we'll focus on SQL. Now, the data that I use is real data. It's not canned data sets. I pulled them off of Kaggle and whatnot. You'll submit your stuff through Gradescope, even if it's late. Always submit it through Gradescope. If I have to reopen the submission, I will. Please don't send email for that. You're allowed to submit each assignment 1 day late with no penalty. But you should submit it the day that it's due. You should only use that extra day if you're having difficulty submitting the assignment. So what we're gonna do here is I used to use Docker containers for this class. It was too much. I'm gonna set up an AWS instance, so basically a large server that you will log into and use MySQL there. So we're gonna set it up and give you an SSH password. SSH is just the protocol you use to log into the server. Many of you have hopefully have used it before, and then a MySQL password to log into the database. Now, I have to caution you that you cannot share login information. So if you cannot log in, if you have trouble figuring this out, you need to get help from us. It is considered an academic integrity problem if you use somebody else's login to log into the system. We had this happen on the final where there were a few people who never figured out how to log in. We couldn't help them on the final. We couldn't give them another login. They needed to know that by week 1. So exams, true, false, multiple choice, short essays, descriptions, and writing queries. I intend for this to be on Canvas, not on paper. Some of it, at least some of it, will be open course materials and open laptop. So I try to, make this realistic where you can keep trying your query until you get it right, and then paste the query in when you get it right. So that's what I'm going for. So part of it will be open laptop. There's no required book for this class, and I realize I need to pace myself better here. We have a much shorter lecture this year. There's no required textbook. If you want to buy one, there is this book, a 7th edition of Silbershott's databases. It's very thick, it's very verbose, it's very theoretical. I'm going to post chapters based on fair use throughout the quarter on Canvas instead. And if you want to read it, you can read the PDF. The 6th edition is very cheap, and you can also get that instead. This book I highly recommend that you buy, though. It's not required, but I recommend you buy it. Learning SQL by Bolu or something. This book is free to UCLA students, but it's an ebook. So if you want to use it on the final, you may need to have a print copy. We're going to cover everything in this book, but possibly in a different order. There's a lot of other good books that I recommend. This one, The Art of SQL, is actually how I taught myself SQL. It's a very thin book, but it just explains it very, very well. There's a couple others. This one's probably better for 405. This one I recommend for anyone who is interested in data engineering, and I recommend it to all of my CS students as well. It's also free for UCLA students. Designing data-intensive applications, so data infrastructures. If you're really interested in what's going on under the hood, this book, which is also free for you, Database Internals, is good to review. Okay, academic integrity. I need to spend some time on this because this is a pretty big problem last year. So UCLA takes academic integrity very seriously, and so do I. There's a zero tolerance policy for violations of the academic integrity policy. If we suspect you of violating the policy, and I actually have a very high bar for what I consider to be suspicious, because it's such a high bar, it just gets sent to the dean. I don't hem and haw about it or give any chances, it just gets sent to the dean. So clarifying requirements of an assignment. What does he mean when he says X? What am I supposed to do for X? Is okay. All you're doing is sharing approaches. That's fine. Helping a classmate find a bug is also okay, as long as you don't share code with them. Using code provided by us, the book, the lectures, the discussion sections, and on Canvas, Piazza is okay. Using sources outside of the class, so require citation. So the reason for this is multiple of you might do this. It gets caught by a plagiarism detector. We use it in every assignment, and then we have to figure out what happened. If you all use like a Stack Overflow post or something, it needs to be cited. That way we know that where you got that information and that it wasn't from collaborating. What's not okay is using solutions from any previous offering of this class or posting your solutions anywhere. So posting them online, posting them on Piazza, or giving another student your work. Oftentimes what happens is you think you have a good friend, they need help, you give them a copy of your assignment. What usually happens is they copy it verbatim. This has happened several times. Also, if you paraphrase somebody else's work, I know. It's actually very obvious. Right, don't work together on the homework. At least don't share the code you're writing. And sharing login information is also not okay. Now, this is really important. ChatGPT and chatbots and generative AI. Anderson has actually taken a different policy compared to the rest of UCLA, as far as I know. Anderson wants students to embrace generative AI, and I do as well to a certain extent. It's very, very powerful, but we are allowed to create our own policies to prohibit its use in our classes. So I'm going to state my policy here is that you cannot use ChatGPT or any other LLM to do any part of any assignment in this class. Repeat, you cannot use any LLM, generative AI, ChatGPT, etc. to do any part of any assignment in this class. You can use it to study, to create sample problems that give you solutions, and to understand concepts. Also, sometimes they're wrong. All right, so here it is in red, cannot use. How will I know? Last year, we had a situation where there was a question on an assignment that people didn't understand. And instead of asking me to clarify it, 40% of the class ran the problem word for word through ChatGPT and all got the same wrong answer. It really pissed me off because I could not send 40% of the class to the dean. If I have to, now that we have a policy, I will do that. So please do not do that. That's how we caught it, because 40% of the class had the same wrong answer. That's how it's usually caught. All right, so any questions on policies or the syllabus? Okay, who am I? So who am I is the Unix command that tells you your username. I've been at UCLA forever. I got my bachelor's degree in math here. It was actually a double in math and stats. A master's in computer science, so here my emphasis was databases and cloud computing and big data. And then a PhD in statistics. I don't do much plain statistics anymore, but my research area was machine learning and NLP, natural language processing. So not purely stats anymore. I've been here forever. This is my 22nd year here. I have seen buildings go up only to be torn down again, to be built again, and get torn down again. Long time. There was no place better than this, and they've been unable to get rid of me, knock on wood. So my research interests I've already talked about, basically, but the commonality is that they all use a lot of data. All right, so some places that I've worked. I've worked at Google. That's currently where I work. I've been there about 6.5 years. I worked at Amazon for a short period of time as a researcher. I worked at Facebook, Meta now, for 2 years. I worked at Riot actually for a short period. I'm not a video gamer, so that didn't work out all that well. But here, I actually did a lot of SQL to the point that it was traumatizing. I realized that my SQL just wasn't as good as I thought it was, and so I really had to go back and study it before I went to Facebook, where my team kind of considered me the SQL expert, which was, I went from very bad SQL to being what they thought was the expert. So that was kind of cool. So you can do it too. And these other two companies are ads companies in the LA area. So right now, I'm a software engineer that works on Kubernetes, which is this orchestration system for distributed systems. And what we do is we don't work for infrastructure for training machine learning models. We work on infrastructure for inference. So companies want to use Google Kubernetes Engine. This is a cloud product. And they have a model, and they send a bunch of unlabeled data into this model, and it gets labeled by the system. we're the ones who are building the infrastructure to help label those instances. So we're not doing training, we're basically doing labeling online, quickly, fault tolerant, all that stuff. But previously, I had a job more closely related to this program. I was a data scientist in search. So what we did is we developed a lot of metrics, experiments, and methodology to test different features of search. And I'll give you an example in a minute. This could include changing search ranking algorithms, which one works better. And how you do that is you launch the feature to maybe 5% of the user base, and you see how they respond to it. Do they seem happy? Are they finding information quicker? Are they scrolling around the page? Do they abandon? Do they leave the search page because they're frustrated or something? All of those metrics are tracked, and then we use that to determine whether or not this new algorithm or new ranking algorithm is good. Okay, so basically all 3 points are the same here, so we'll keep going. A feature that I helped develop, we spent 2 years on this, is a product that some of you have probably seen. You type in a long query that's very specific, you hit the search button, and you get a message that says, it looks like there aren't many great matches for your search. This is basically Google's way of helping you, rather than just showing you a bunch of crap results that don't answer your query. Users get frustrated, including myself, when they get bad search results. So this tells us we don't think there's good results here. This took 2 years to develop to make sure that the users liked it and that it was useful to them. Another one involves, was more specific to disasters where information is coming in quickly, and politics where information and bad information is coming in quickly. What's called filling the void. So if we detect this, if we detect that there's some new phenomenon happening and we don't feel that we have good, trustworthy results, we get the message, it looks like these results are changing quickly. Come back later, search later, so that hopefully you get more consistent, stable results. All right, at Facebook, this is more of a machine learning role. I helped develop a sentiment analysis system, their first one, and a topic identification system. And this was all done at the enterprise level. So these companies paid a lot of money to Facebook in order to give custom reports about engagement on ad campaigns and also page campaigns. So Coca-Cola, at Christmas time, they had the Santa bear with a hat. They wanted to change the color of his hat for some reason to blue, and they wanted to test the red hat versus the blue hat and see which one people liked better. And so we used a sentiment analysis system to look at the comments under the campaign in order to determine which one they should go with for the holiday season. So some career advice really quickly, and I'm going to say this at the end of the quarter as well. Focus on the job description, not the title. Data scientist means a bunch of different things, and you may be very unhappy in the position if it's the wrong fit for you. So focus on the description. Don't just look at business analyst. Look at data scientist, maybe even data engineer, and look at the description, not the title. It's very important. Okay, I need to speed up here, I think. Yes. Good to know. So there's a couple of slides missing that these are some of them that I will make sure I update when I post online. So this is a typical data architecture. We always start with some kind of data sources. So this could be text, this could be CSV, it could be a bunch of other things. It could be JSON. Some of you are familiar with that format. If you're not, don't worry about it. It could be something like Parquet or Parquet, which is a binary format. If you don't know what that is, don't worry about it. But some of you are advanced and may have heard of it. So I'm trying to, satisfy your cravings here. Now, these the data could go in one of two avenues. It can go into a storage system, which is typically a hard disk or an SSD. So that's data storage. And then we do batch processing on top of this data storage. So this is typically done using SQL or MapReduce. And the data may come from a database. So the SQL is going to run on a database. But it could also actually run on top of MapReduce as well, on Spark or Hadoop. What do we do with the batch once we're done with the batch processing? So we've processed the data. We can then use it for machine learning purposes to build a classifier. Or we could aggregate the data and store it in an analytical data store. These are sometimes called data warehouses, and they use the OLAP principle, which we'll talk about later. Don't worry about it. Or we can use this data for analytics and reporting. So creating dashboards. A dashboard is a user interface that lets you investigate the data, like maps, pie charts. You click on the pie chart and it expands and you can see, various aspects of the people within that slice of the pie chart. Dashboards or reports. That's analytics and reporting. So there's at least 3 things you could do after you've batch processed the data. So we're mainly going to talk about in 402 this space here, the batch processing space. We'll do a little bit of reporting in the sense of computing aggregates, but we won't do machine learning or analytical data stores. This is 405, and this is 405. So that's next quarter. You have a machine learning class. I don't remember what number it is. Now, there's a second avenue that you may not even touch in this program. It's more of a software engineer or data engineer thing. That's real-time message ingestion. So data is coming in very, very quickly, like tweets and whatnot, and we cannot store all the messages. But we know a priori beforehand what we want to compute, the aggregates we want to compute, so the group buys we want to compute, and what we want to count. What we do is instead of storing the data, we stream the data through a processing system that counts stuff, so you only store the count rather than the data. This is actually a very interesting computer science problem. That can then be used for machine learning, training, or inference, and it can also be used for analytics and reporting. So just a quick summary of this stack. Every company has this stack. This is sometimes called the Lambda architecture, or similar to the Lambda architecture. Underneath that, you have some distributed system, so a mess of computers and servers that handle all of this. Okay. So what are you going to do? And you're going to be designing and executing experiments and observational studies as a data scientist typically, communicating with non-technical stakeholders, analyzing and modeling data, extracting data using SQL and MapReduce, sometimes developing algorithms like recommender systems or classifiers, diagnosing model issues, but 95% of your job is cleaning the data. And when I've done interviews for the data scientist role, I've had some people tell me, I hate cleaning the data. That's an automatic no hire for me. And I write it very, very strongly in bold that the candidate said that. You have to like cleaning data, or at least don't say you don't like doing it. So what should you learn in order to do this? Take a wide variety of math, stats, and probability classes if you haven't already. Many of you are math and stats, so you're good there. Take a machine learning class, you will. Learn SQL, you will in this class. Learn R and Python. There's a lot of arguments about R versus Python. At my employer, R is more common than Python. At most employers, it's the other way around. Play with lots of different data sets. So there's a website called Kaggle where you can download many fun data sets that you can play with. You can also scrape or crawl data by scraping a website. Okay, now what I really need to get into in the last 30 minutes, actually we have a decent amount of time. I'm glad I cut this shorter than I thought I needed to. So, introduction to databases. What is a database? Most of you know what a database is already, but let's have a theoretical working model of what it is and the various data models that you may work with. So a database abstracts away how we retrieve, process, and store data. So you don't have to worry about where is the data on the hard disk. You don't have to worry about indexing it and finding that data quickly. You don't have to worry about having inconsistency among files. So my CS class, I give a use case of UCLA's old student record system, which is based on flat files. So when you have flat files, what could happen? The files could get corrupted. You could have multiple people try to write to the same file and clobber, or multiple processes try to write to the same file and corrupt the data that's in that file. This actually happened. A lot of alumni lost their transcripts. These are people from like 30, 40 years prior to the transition because of this problem, and they had to piece it together from other sources. Now, so a database abstracts away all of these really complicated things, but what's old is new again. Many of the big data systems like Hadoop and Spark require understanding how data is stored in order to efficiently run a job on a cluster. So you also need to understand how the data is laid out. So I mentioned Parquet earlier. Parquet is a binary format. You just load it in. You don't have to parse, comma-separated values. You load it in and you use it. So it's important to understand these different formats in order to use a big data system, but that's not what we're talking about in this class. You just write queries. It provides one way to create, read, update, and delete data. This is called the CRUD operators. Create, read, update, and delete. Without having to worry about corruption or data integrity issues. It provides one location of where you do all this. One machine you log into to do all this. Now, the database may be distributed across multiple nodes. It doesn't matter. You write all of your SQL in one terminal on one machine. The overall design of a database, so the different kinds of data that it stores, the different kinds of functions you could run, the different permissions involved, this is called a schema. So we're going to use that term a lot. But the word schema is actually overloaded in databases. A schema also refers to the layout of data in a table. So if you don't know what a table is yet, don't worry about it. But it's where we store data, essentially, in a database. And the schema is the format of that data and what data types are used within that data. So it can be used to describe both. We're just going to use the word schema. Now, relation is a theoretical term that I'm going to start using, and then we'll switch to table later on. Now, there's a bunch of data models, a bunch of different ways to store, abstractions and implementations of how to store and retrieve data. How do we define data? What does it look like? How do we encode the relationships among the data? And how do we impose constraints on the data? So certain columns can only take certain values. There's 5 major types, and if I have time, I'll go over 2 more that are important. The first is the relational model. This is what we're going to focus on in this class. Data is stored in relations, which is also called a table at the practical level. Rows represent individual records or tuples. So we're going to use the word tuple here that represents an ordered representation of each record. So rows represent tuples or records. Columns represent attributes that are common to all records and have specific types. So we're going to use the word attribute at the beginning here rather than column. And they all have a type. So here I have 4 columns, buildings, the number of floors in the building, the number of access points, and the number of rats that live in the building. The first attribute here is building. In implementation, this might be a varchar. Don't worry about what that is yet. The number of floors might be a tiny int. So it has a range. The access points might be an integer. And the number of rats is hopefully a tiny int. So hopefully only up to 128 rats in a building. Otherwise, we have to promote to a different type. So hopefully you're all familiar with the relational model. Implementations of this are MySQL, Postgres, DB2, and Microsoft SQL Server. There's some others that are a little bit more tangential, like Microsoft Access and some other things, but these are the main ones. Entity relationship, going back here for just a moment. Relational is an implementation. What this means is that the database is built to be relational. It uses tables under the hood, as opposed to the entity relationship model, which is a design construct. There are no ER databases. ER is used for design and describing databases. Every box that's in the ER model represents an object or a noun. And it's equivalent essentially to a relation. Every circle that comes off of this box is an attribute of that noun. So this is technically called an entity. And every circle that comes off of it is an attribute. So these are attributes of institutions, a category, a homepage, an email address, and so on. These edges represent the relationships among the entities. So here I have N and M here. I don't remember which one is which, but basically it's saying that every institution has M experts, so faculty members. And on the other side, every expert belongs to N institutions. So faculty member can belong to multiple universities, essentially. So that's what this edge here represents. It's the relationship. In the relational model, how do you represent this relationship? For those of you who have used SQL before. This is actually good. You'll learn a lot then. Using a join, joining two tables together. That's how you represent the relationship, and a join key. All right. The object-oriented model is both an implementation. So there are databases that implement this design, and it's also a design model. Now, we're not going to talk about this. Is kind of old-fashioned. But has anybody used Gemstone or Cache or Versant? These are all object stores. Basically, you interact with the data as if it's a bunch of programming classes and instances of classes. And every instance has member variables and member functions that you can call in order to exploit relationships among these objects. Now, usually it's used as a design mechanism these days. When you're coding in SQL and using a web app, for example, oftentimes you're going to use an object-oriented model in order to do that. So instead of writing SQL, you create a bunch of classes that represent the various tables, and you simply use that object to interact with the database. So this is called an ORM, or object relational mapping. If you don't worry about it if you don't understand this. Basically, you create these classes and it writes SQL for you. But some of you may have seen this. So again, I'm trying to satisfy your cravings. Document database. So in the document database, every record is a document. And they may or may not share attributes with other documents. You can have a document that doesn't share any attributes with other documents, or they share a subset of attributes. An example of the document model is maybe a library retrieval system. So you have various different things in a library. You have books. Every book should have a title, but not every book has an edition or what else? Or we'll stick with edition. Not every book has an edition. So we don't need to specify an edition for each book. Instead of putting null for the edition, we just don't put the edition attribute in there at all. We don't have to. Every document can have different attributes. So a puppet, the puppet isn't going to have a title or an edition or an author. It's going to have, what is it? Is it an animal? Does it talk? What is its name? What character does it represent? Completely different attributes than a book, but they can be stored in the same database. Typically, JSON and XML are the formats that are used to store this data, and we'll talk about JSON in this class. These are considered NoSQL databases. It's one type of NoSQL database. What is a document database you have heard of? Anyone? Just shout it out. Has anyone heard of MongoDB? Okay, a couple of you. MongoDB is an example of a document store. It's typically used as a backend for websites or blog posts and whatnot. By the way, I forgot to mention this, all of this stuff is posted. So all the slides that I'm writing and the recording will all be posted. So feel free to take notes, obviously, that's what you're here for. But if you miss something, it'll be posted as well. I see some people frantically taking notes. That's good. This is what JSON looks like. It's a nested format. So here I have, this is from a weather station. You have a bunch of nested data. You have, when the record was created, the language that it's in, and then within that document, you have information about the weather observation. You have the condition, a particular code, which is like mostly cloudy. You have the date that this recording was taken, and the temperature. Now I could have more observations embedded within this document as well, within this JSON format. This is an implementation. So document databases are built from the ground up to be document databases. Sometimes we call them document stores. MongoDB is a database though. For those of you who have played with databases, they use ACID transactions and a bunch of other stuff that's common in databases. How are we doing? This is a lot of information. It's high level though, so don't worry too much about it. When we get it in next lecture, will be lower level, more critical. This is XML. I won't talk about this because it's very old, but you may see it from time to time. It looks like HTML. It's incredibly difficult to program in my opinion. It's broader than HTML, actually. It uses namespaces and all this other stuff that we don't need to worry about. Anybody know of another document store that uses XML? MongoDB is kind of the king here. There's one called CouchDB that uses XML still. One of my favorites is the network hierarchical or graph model. The original database systems, when they were first developed, followed this model. The reason why is because in our brains, this is how we connect ideas. Basically, every idea is a node, and every kind of relationship among ideas is an edge between those nodes. That's why in machine learning, we have the concept of a neural network. And how our brain actually works, this isn't just a model, an abstraction. Our brain actually works this way. There is a thing called a neuron. It's not a thought, but it makes up a thought. You have a finite set of these at any time. And my horrible drawing here. And the neurons, you form thoughts by these neurons connecting with each other using electrical charges. So there's what's called the tendril, which is this little thing, this little guy here, that sends an electrical pulse across what's called a synapse to communicate with another neuron. And so that's where neural networks come from, same type of communication, but also this network model is kind of an abstraction over how we think. So it defines records as nodes, individual objects as nodes, regardless of what they are. Nodes can have different types representing different kinds of objects, and the relationships among them are edges. One notable example is Neo4j. So if you're a CS major or we're a math major and you took like graph theory or combinatorics, it's the same kind of thing. One example is Neo4j. Here's what YouTube looks like in a, yeah.
Do you clarify what you mean by a NoSQL example?
Yeah, so NoSQL. NoSQL, so there's SQL and there's NoSQL. The term NoSQL is very controversial. It means one of two things. It could mean that the database doesn't use SQL as its language. So MongoDB, for example, uses JavaScript. So that is a NoSQL database. It doesn't use SQL. That's one definition. It's a lazy definition. The other definition is that it is essentially not a relational design. So typically only the relational model uses SQL. So they're correlated. The two definitions are correlated, but usually it means a database that's not a relational implementation. So network and document are two models that are NoSQL examples. Does that help? Great. Okay, so here we have YouTube in a graph. You see I have two kinds of nodes, green and blue. The blue nodes represent users, and the green nodes represent channels, YouTube channels. And you see there's a variety of edges emanating from each node. From the David node, I have an edge called operates. This is a specific kind of relationship between him and a channel. He operates a particular channel called Disco Dancing with David. He has, let's pick another example here. I have Bob. He operates a channel, so there's an edge there, called Bob's Cute Dog, and he operates another channel called Bob's Gaming Channel. But there's another relationship involving him as well, called the subscribes relationship. He subscribes to Disco Dancing with David. So he subscribes to a particular YouTube channel. So you see there's a lot of different edges emanating from a node and a lot of different kinds of nodes. These are super, super cool databases. I love these. How would you navigate through this graph? So you're coding a query. How do you navigate? So for example, find all of the friend of a friend or something here. We'll just make something up here. How would I navigate through this graph? If you're a CS person, this should be on the tip of your head, tip of your tongue. Anyone? All right. You don't need to know this, so don't worry, but I like this. There's two ways to do this. You can navigate through a network using breadth-first search, and that is how the query would execute, is using breadth-first search, or depth-first search. And you can use your favorite algorithms. Others are like topological. You look traumatized, like you've been through this. There's also algorithms like topological sort and Dijkstra's algorithm for shortest path that are used for I'm sorry, I know it's early too, that are used for data-related problems. How do I find the nearest channel to a particular user, or how do I find the nearest a navigation database? How do I find the nearest park to where my car currently is? I could execute that query over a graph database. Now, how many more slides do I have so that I can maybe cover? These I can get through quickly. I'm going to mention two other models. Don't worry too much about them. One is called the vector database model. This is used, it's important because it's used in generative AI and a lot of these large language models. Instead of storing individual rows and records in a table, we stored vectors in this database. So Amazon, for example, has recommendation systems. Every item has some kind of numerical representation associated with it, like in an embedding. Who's heard of embeddings? Like word to vec? Okay, some people. If you're a machine learning person, if you're not a machine learning person, ignore me for a moment. Every item can be represented in a bunch of numbers, basically. Every word can be represented with a bunch of numbers in some kind of high dimensional space. So if you're a stats person, this could be like principal components analysis, factor analysis, or something else, multidimensional scaling. And these numbers represent a point within this hypercube, or this higher dimensional space. So a word has a vector associated with it. Every word or every item in Amazon has a vector of the same length, and we store all these vectors in this database. We store them with a name maybe, or some metadata. Then, given a particular book, I want to query this vector database to find the other books that are most similar to it. So I build an index over all these vectors, using from computer science again, something like a KD tree or a ball tree, that finds all of the vectors that are closest to that book. So all the books that are closely related to that book. And then I return those vectors as books that you may want to buy, a recommendation system. So I'm just talking a lot here. I don't have a slide, I'm sorry. Maybe I'll add one. That's the vector model. It's really important right now for fast retrieval of vectors. And how do we see if two vectors are similar? There's a lot of distance metrics like cosine similarity that do that. Anyway, hopefully I didn't lose anybody or scare anybody. Don't worry about it. The other one is the key value model. These typically are implemented in RAM. So not on disk, they're in memory. System goes down, you lose what's in memory. You usually cache stuff here. You store stuff in memory temporarily. And typically it's a key value pair. A key representing what the data is that gives it a name, and a value that represents the record itself. So if I want a particular student's email address and I know their UID, the UID is the key. I ask the key value store, here is the key. It's going to give you back your email address and maybe other stuff as well. Very simple model. It's a function. Gives me back actually it's not a function. It's just a key to a value. It's a mapping, a one-to-one mapping. There's one more model. It's called the hybrid model. Some databases implement multiple models. ArangoDB, there's a lot of these now. People can't pick a model, so they pick a database that has multiple models, implements multiple models. ArangoDB is an example of this. And so those are good to know about. Anyway, are there any questions on database models before we finish off in our last 9 minutes? So there are two languages involved in a database system. The data manipulation language, which you use to manipulate data and to retrieve data and update and create data, and the data definition language. So the DML is for CRUD. The data definition language specifies schemas and other things. In the relational model, both of these are SQL. Now, I won't judge you if you pronounce this acronym a different way. I say SQL, it's easier. Other people say SQL, that's perfectly fine as well. I can usually tell when you write it, how you pronounce it. If you put an SQL query, I know you're saying SQL. If you write a SQL query, I know you're saying a SQL query. So SQL is one group, SQL is another. I'm in the SQL group. And then there's hipsters that use other ones like school, for example. I've never heard it, but apparently it happens. So a meme here, the most enlightened person says structured query language. Little less enlightened says, actually, maybe this is the other way around. It's the other way around. I don't know why somebody was, anyway. A little more enlightened is SQL. More enlightened than that is SQL. So we'll put a happy face here. And then the most mind-blowing thing is school, squeal, squiggle, and my favorite, being at UCLA, squirrel. Yeah, so use anyone, I won't judge you. But I did post on Twitter a poll, how do you pronounce this? And 55% said SQL. 43% said SQL, and 2% said other. I don't know what that was. Yeah. So we try to keep it light in this class. The data, so I already covered what the DML is. It's a query. That's how you pronounce the word, is query. Some people say query or query. It's query. Is an expression that you use to retrieve or manipulate data. The query language is just the language it's written in. So it's SQL. Okay. Now, the DDL. The DDL specifies the format of a table or of various objects in a system. It specifies the schema, for example. It specifies the attribute names for a relation and the data types for each attribute in that relation. It also specifies consistency constraints. Now, I want to spend a little bit of time on what that means. This could mean no duplicates, no duplicate attributes. So for example, every student has a UID. There are never any duplicate UIDs at UCLA. They're never reused. Social security number, I think that actually may be reused, but over a very long period of time. So no duplicates, that's one consistency constraint. The data type is another consistency constraint. I'll talk about another one in just a moment. I won't write it here because it's a little bit complicated. I want to be able to explain it. Optionally, we could specify how the data should be stored. If you're a DBA, a database administrator, you worry about that. And access methods. So this is more like permissions. Who's allowed to do what on the relation? We won't talk about permissions in this class. So there are several constraints, consistency constraints that we can impose. A domain constraint. So for example, a tiny int. I'm forgetting at the moment how big this is. I believe it's, signed, it's -128 to 128, so there's a range. And unsigned, it's 0 to 255 or something like that. So that's a domain constraint. You also have a type called an enum, and we'll talk about this in more detail later, that represents something categorical, hair color, student type, major, one from a set. In R, these are called factors. If you've used R, Python has an enum type. Anyway, referential integrity, this is the one that's tough to explain. What referential integrity means is that if I have a table that has a particular row with a specific value for an attribute, say this one, the instructor attribute, and I have another table that table relies on. So I have a courses relation, I have an instructors relation. In the courses relation, I have information about courses, including who teaches the course. There's an implicit relationship here, it's actually explicit, that whoever is teaching that course better be employed by the university. They better exist in the instructor's relation. And I do here, there is a row corresponding to me. This is good referential integrity. What it means is that whenever I enter a record into the courses relation, it must be associated with an instructor that is employed by the university. If I don't, if I put some random name, I will get an error. If I put no name, I will get an error because that instructor does not exist in the instructor's relation. So who isn't represented? They're all represented here. If I put Knockenberg here, that would not work because he is not in the instructor table. This isn't a bidirectional relationship though. I'm allowed to have an instructor that teaches no classes. They're paid to do other things like research. So that's referential integrity, and we'll talk more about that later. But are there any questions about what that means right now? You guys are either like really tired or like really on top of things. And reading through the slides, it seems like this group is much more technical than previous groups. We also have the concept of assertions. These are business logic rules. And if you're not technical, don't worry about it. That's why you're here. These are business logic rules. For example, if I have a relation that contains the student name and ID and the number of units they're taking. An assertion is that the number of units cannot exceed 18 or 20 or whatever it is for the undergrads. That's an assertion. It's not part of the schema per se. It's not part of the data types or the domain constraints, but it's something that's checked when we insert a row or try to change a row. Authorization, these are permissions. So are there any questions about the DDL? Now, there are other models aside from the DML and the DDL. I'm forgetting what they are. One's like the transaction data model. Don't worry about that. Your book only covers 2 of them. Some people have done a lot of databases stuff and have corrected me, but there's actually like 5, 6, or 7 of these. A database is a very complex system. You're up here. That's my little sound effect when I draw a person. Here I am. You're up here. So you're a sophisticated user, an analyst, basically. And you're basically going to stay up at this level. Some of you may go lower here, but this is mainly where you are. You use query tools. Some of you may be application programmers. You do that. So you write programs or whatever. But all of those programs get sent into compilers and linkers and interpreters that convert your query into math. There's a whole, talking about CS again and algorithms, dynamic programming algorithm that picks which relational algebra expression you should choose. I'm laughing because you're probably thinking, boy, I don't know if I should do this. I was trying to get away from computer science. No, computer science is very, very relevant to analytics. And that's where I'm from. Then under that hood, you have the file manager, the transaction manager, the buffer manager. Who cares for this class? And then the storage of where the data actually lies. Now, there is actually statistics used here. When trying to optimize a query, a lot of statistics are computed about the load on the system, CPU, memory, and disk space, what other stuff is running on that server or in that database. All of these statistics are used in order to pick the most optimal query. Now, what I'm thinking is going to happen is that we're going to start using machine learning down here. We can build models that are able to predict it with good accuracy. These models work well, they don't work great. With really good accuracy, we can pick the best, what's called query plan, based on some machine learning model. So that's really exciting. Okay, so that is it for the content for today. I have a couple of reminders, and we're actually right on time. Please fill out the student survey for credit. There is an academic integrity agreement that's basically making sure that you are aware of the ChatGPT prohibition in this class. There is a syllabus quiz because I couldn't print the syllabus out for you. That's also worth points. It's worth 20 points. One of them's a freebie. One of the questions is a freebie. You can retake the quiz until you get 100. It's about making sure you understand the syllabus, not punishing you for not understanding the syllabus on the first try. And make sure you have access to Piazza. That's very important. I'll be here for a little bit if there's questions. Otherwise, I look forward to working with you all this quarter and next quarter. Have a great rest of your day. Go back to sleep if you need to. And I have a big break until my next class at 4.